basically swap. So we're trying to find how fast it's going. What do?
We could just start plugging in the answers, the numbers.
Okay. 3 times 9.8 times 20 equals 1/2 times 3 VF squared. Now what? This?
Yes.
588 is equal to 1.5 VF squared. Say it again?
392.
All right, so you divide by 1.5, I assume.
Yes.
So we have VF squared equals 392.
So 19.799.
Meters per second.
Here we go. When we did it this way over here, we had set 19.796, 799. I hope you recognize that rounding difference. But we get the same answer, or at least close enough for physics. Ooh, chapter 3 or chapter 7 get the same answer. All right, so now the next bit. It's going to make a dent in the ground. So it stops. If something stops, what does that tell you? Is
zero.
yes. So it's going to go from 19.8 meters per second to 0 in that amount of time. All right, well, I know that the change in momentum, so I'm trying to find average force. So change in momentum is equal to impulse. This is mass times, well, let's actually put in the intermediate step. That's P final minus P initial is equal to force times time. Formula for momentum? Question mark? Yes, MV. Final minus mv initial is equal to force times time. Well, I know time. I know mass. I know VF and VI. I got everything except for force. Plug and chug. So it's 3 times VF, which is 0, minus 3 times VI, which was 19.7, oh, I'll use that number, 799, is equal to that average force times 0.01 seconds. That's meters per second. That's kilograms. Kilograms. said negative 59.397? Oh, just that side.
Yeah.
Negative 593.97.
You said 593?
Negative 593.97.
I think you're off
Oh, I think
by
it
a
did.
decimal point.
Yeah, I think it did 0.1. Okay.
Should be 2 decimal places, so 5,939.7 units.
Newtons.
All right. That's the average force exerted on this while it stopped. Let's assume there's no friction involved, it just hits. What's the main force causing it to stop? Okay. So if we look at the rock as it's going into the dirt, what are the forces acting on it while it's sinking in, after it's hit the ground?
Weight and normal force?
Yep, we got weight acting down and normal force acting up. That's my total. Now, not stated explicitly this time, but down is positive still. So I know that my weight minus my normal force, and let's see if I can do that better. Weight minus my normal force is equal to negative 5,939.7 newtons. How do I find the weight of the rock? So that's 3, that's mg. So 3 times 9.8 minus y is equal to negative 5,939.7 newtons. And so my normal force, the average normal force as the rock sinks is going to be 29.4 plus that. Questions to here? All right, so that's all. So how deep was this dent or hole? Now, we have the total force acting on it. We can divide by mass, find the acceleration. Yeah, we can do it with chapter 3 stuff. We're not going to though. Chapter 7. Energy again. Now there's 2 forces acting on it while it's sinking in. Weight, conservative or non-conservative?
Conservative.
Normal force, conservative or non-conservative?
Non-conservative.
All right, so what we have here is no conservation of energy. Technically, the energy the rock loses goes into the ground, but with the rock itself, energy is not conserved. So we bring out our standards of the work-energy relationships. I know that non-conservative work is equal to the change in total energy. Conservative work is equal to the negative change in potential energy. And total work is equal to the change in kinetic energy. And I know work is force times displacement.
The U is potential energy, right?
That is correct.
Okay.
So, of the work energy formulas, which one do you think is going to be most convenient?
Wouldn't it be the potential energy?
This one right here?
Yeah.
So the potential energy. So let's see what we get. All right. So conservative work is conservative force times displacement. And that's equal to the negative of U final minus U initial. All right, let's just establish it now. Where do you want to make H is equal to 0?
The ground.
Okay, so at the ground. So my initial potential energy is 0. Because Layla said so. My force is this is the conservative force, so that's 29.4. Times my displacement is equal to the negative of my final potential energy. Oh, and H final will be a negative number. That messed up with signs there. All right, so what is delta x besides displacement? Physically, in this problem, what does delta x represent? Jonathan?
When it's the ground, or
What part of, you said when it hits the ground?
isn't it when it makes when it hits the ground, it makes the dent? Is that what it is?
Yeah, so delta x is how far the dents?
Yeah.
Okay, yeah. What is HF?
The final height.
Which is basically, since the ground is 0, that's how far it dents. So this equation right here, we basically have this delta x and this HF are the same number. So all that's going to end up telling us is that mg is equal to 29.4. So that equation, so that middle equation right there is not going to help us, unfortunately. But in a physics problem, one doesn't work, we try another one. This is not going to help us, so what about the other two? Or which one do you want to try next?
Let's do total.
Total? All right. Let's get rid of a bunch of this stuff. Oh. All right. Whoever told me about that, thank you. All right, so total work, that is the total force times displacement, is equal to my kinetic final minus my kinetic initial. It's coming up on that moment again. Total force we know, that's this right here, that's my total force. That's what we're trying to find. That's what we're trying to find. What's the formula for kinetic energy?
1/2 mv squared.
Alright, so 1/2 mv final squared minus 1/2 mv initial squared. Either of these equal to 0. Just from the moment before it touches the ground to making the hole or dent. I guess we'll find out which one it is.
The initial velocity.
Why initial?
Because our final because it hits the ground.
And stops.
Yes.
Yeah. We've basically broken this, try again. Basically, we've broken it up into two problems. We've got the falling part and then we have the stopping part. We're in the stopping part now. So my initial speed here was my final speed for the first part. So that is 0 because it does stop. Stops. So I got my total force, negative 5,939.7 times my displacement, which I'm trying to figure out, is equal to 0 minus 1/2 times 3 times 19.799 squared. Negative something. Should be just shy of 600. What is it?
I believe it was 588.0006.
588. And that's equal to my 5,939.7 times the size of the hole. Therefore, the size of the hole is, we divide both sides by that to get my delta x by itself, so I got 588.0006 divided by negative 5,939.7. There's my delta x. Wait, 0.098995 units.
Meters.
So the hole's about that big. Or dent, whatever, whichever it ends up being. Likewise, I could have also told you how deep the dent was and then figured out how much time it took. Questions to hear? Just building on the energy I'm feeling. Yes?
So,
You have a question or you resolve it?
I'm formulating, I'm trying to think how to condense. So, how would we have found so I guess to find the time, we would have had to do the non-conservative work formulas, because neither of the other two formulas
Oh.
have time as a variable.
Define time, if I had done it the other way?
Yeah, like,
If I done it the other way, we would still find, but if we done it the other way,
that
we would have
wouldn't
known
have a
this,
variable.
we would have found force. And then we would have plugged into the impulse momentum equation to find time. You're not gonna find time directly from these equations.
Okay, that's what I was trying to see, is I was trying to solve, like, find where time fit into the variable, but if you then would find force.
Yeah.
And then, that's what I got confused, is I was trying to figure out how you would solve for time whenever none of them had time as a variable.
Yeah, if you wanted to not use the impulse momentum, this would find force, would then find, from that you can find acceleration, and then from that, you know what the initial final velocities are, so you find time that way. Impulse momentum is faster. It just comes across like it's a dreary day or something. Is this post-test blues or is this the rainy day outside blues?
Yes.
Both. Well, I'm gonna hand test back. I had no tears of joy, but there were no tears of sadness. It's not sunshine and roses for everyone, but overall, I was pleased. Did I have this test posted and just forgot?
Not yet. No, I don't think so.
Okay. It wouldn't affect your grades, I mean, it was posted, but, the last problem, 3 people got right, completely right. And I think that's a record. So, number wise and obviously